All right, thank you. Thank you so much. Okay, so I'd just like to share my screen, do a few things, and all together, just I'd like to just take a few moments to explain some things to us. Okay, so if you can see my screen, please signify. If you can see my screen, it's okay. I'd like Isoken to be my spokesperson.
I can see your screen.
All right. So what I mean by spokesperson is whenever I ask a question, okay, can you hear me? I used to hear me and all.
Okay.
Just, exactly. He seems to be in a great environment as well. So I hope that's not too much to ask.
No, 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 it's not.
Oh, okay. So let's get started. If I may ask, what do you know about SQL? Anybody here, what do you know about SQL? Have you worked with any RDBMS software before? So what do you know about SQL? Let me call Abdullah.
Yes.
Okay, what do you know about SQL?
So actually, I know that SQL stands for Structured Query Language.
Okay,
So more like a database management tool. So they
okay,
will also be used for analyzing data. So
mm,
yeah.
okay, all right. Thank you very much. So one more person. What do you know about SQL? What do you know about SQL? One more person. Maybe I call someone else. Pa, 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 pa. Okay, is Alima there? Alima, what do you know about SQL?
Yes, I've only heard that it's a language, like
Okay,
it's a kind of language used in data analytics, but I don't really know much.
okay, oh, okay, all right. Okay, so let's start the class by introducing ourselves to a few things before we even get practical. Um, Now SQL is a language. SQL is a language, a database language. The same way English is a language that we speak. Now, SQL, like Abdullah rightly said before, stands for Structured Query Language, and it is a programming language that is used to manage data in relational databases. Now, just the same way, one thing that we used to um, misconcept about SQL is that some of us say, oh, okay, it is a tool. Some of us say, okay, it is a language. So then, which one do we actually call it? Now, SQL in itself is a programming language, just the same way Python now is a programming language. But if you want to write Python codes, you can use different IDEs like Colab, like Visual Studio Code, like Jupyter Notebook, and the likes. But that does not take away the fact that Python in itself is a language. That's the same way SQL in itself is a programming language. Some people like to call it a database language because that's what you use it for, to manage data in relational databases. You can use it to query, insert, update, and delete data that is stored in databases. So SQLs, you hear some people say SQL, or some people even call it SQL, as most of you might have heard other people pronounce it. So whichever one you want to call it, SQL, SQL, we are still talking about one language here. However, when we start to talk about tools that we can use for the language, when we start to talk about tools that we can use for the language, now that is where understanding databases and relational databases come in. Now, it's a very simple example of what I can use to define a database. Is, a database is an organized collection of information that can be searched, sorted, and updated. Now, take for example your contact log on your phone. That's an example of a database. Because if you want to call somebody now, you can pull up their number, pull up their contact, and your contact returns data on that person. And then you can say, oh, let me call Favor. Oh, let me call Abdullah. That's an example of a database on our phones. Now, you see, the thing is here, databases are like spreadsheets, but there are several key differences between a database and a spreadsheet. And the major difference is that, you see, with databases, you can store much more. That is, you can store larger information. You can protect data better, and you can handle a lot of information in one place without hassle. Now, most times, some people ask, if I've learned Excel so well, if I've learned this so well, why do I need to learn another tool? Now, you see, the truth is, knowledge of tools will never cease to end. Even the moment you think you know one, another one then comes into the picture that you need to learn. But you see, for any data analyst, the knowledge of databases and SQL is absolutely important. Not because you cannot handle large data in Excel. If you are able to use what they call Excel's power features, as Power Query and Power Pivots, and you have a very good laptop, you might be able to handle large data there. But SQL gives that freedom that you need to handle large databases. I already defined what a database is and gave us examples. Now, when we're talking about databases, there are two main types of databases that I'd like us to know, to keep in mind. Now, we have databases are usually dependent on the kind of information that it contains or the kind of structure. Now, they are usually the relational database as one type of database. Now, relational databases is usually data that is stored in tables. And we know from my Excel knowledge that a table consists of rows and columns where you have records being stored. Now, SQL in itself is a language that we use for communicating, or should I say, querying and manipulating these relational databases. And that's why tools that we use to write SQL codes are called RDBMS tools or RDBMS softwares. In the slide that I shared, you are going to see some examples of some of these RDBMS tools. Now, other types of databases include NoSQL databases. These are mostly called unstructured or semi-structured databases. Databases that you find people like web developers working with. We also have cloud databases, platforms such as Azure, Amazon, and a few people run non-physical databases. Now, I hope we're still together, please.
Yes, for me.
Oh, all right, thank you. Now, I already mentioned before that a relational database is what we are going to be dealing with inside of SQL. We know that a relational database consists of data that has been organized into one or more tables within a database. However, what makes databases in SQL unique is that you can have more than one table. Just the same way, even in our spreadsheet, in our workbooks, we can have more than one sheet. Now, what makes these tables relational, just like you learned when you did data modeling in Power BI, is something exists between these tables called relationships that we define using primary keys and foreign keys. And I remember from our Power BI classes when we were learning about Power Query and data modeling, Miss Blessing spoke about primary keys, foreign keys, creating relationships between multiple tables. Am I right? So
Yes.
before
Yes.
SQL as and the relational database management tools, it's important to know certain things. Number one, what SQL is. Number two, what a database is, the types of databases, what a relational database is, and then what an RDBMS is. Now, I said earlier that why SQL is a language, the tools that we use for writing these languages are is called a relational database management system. That is any software system that you can use to create, update, and maintain relational databases qualifies as a RDBMS tool. Now, some examples of this RDBMS tool may include SQL Server, Microsoft SQL Server, which we are going to be using during the course of this class, MySQL, PostgreSQL, Oracle Database, Microsoft Access, and SQLite. So all of these now are tools with which you can use to write SQL codes, SQL queries. So I hope we now understand the difference that SQL in itself is a language, and these are tools that we use for writing SQL queries. Now, moving on from here, I would like to dwell too much on this, but one thing I'd like you to know is that the material will be available on the classroom. So please ensure you download it, read it, and digest it. If you have any questions, you can always relate back on the group. Now, when we talk about a relational database, I mentioned before that it contains tables. Now, there's no understanding databases without understanding how data is handled in the tables. And you see, data types are very essential in SQL because what a data type does is that it defines the kind of data that can be stored in tables, in columns that are in tables. Take, for example, even in our Excel, when we were learning from the basic, I remember Miss Emanuela um, informing us that when she was teaching us data types, that there are different data types that you can enter for each column. That's the same way in SQL. There are quite a few data types that we should get familiar with. And as we go on, we are going to get familiar with some of these data types. Now, I'd like to group the data types that we have in SQL into two. I'd like to group them into two. I say we have the string data types, the numeric data types, and then the other data types. So let me say three. String data types are data types that have to do with text or varying character entries. And under this, we have data types such as the char data type, the varchar data type. This varchar data type is also called varying character data type. If you have a column that contains a mix of numbers, text, and maybe symbols, the best way to handle that kind of column would be to define it using the varchar data type. And rightly so, all of these data types have been properly defined within this slide. So as you go through this, you'll be able to understand. Don't forget, I said that the data type defines what kind of data is allowed within a specific column. So if a column has been defined to a certain data type, and we try to put in a data type that is not of the defined order, SQL is not going to allow that. So under the string data types, we have the char, the varchar, the text, the end varchar, the bits, the binary, the var binary, and the var binary max. The major difference between most of these is the number of characters that they allow. As you can see that some of them have character limits, just like sending a SMS on your phone. There's a point you will get to where the charge will not just be for one SMS and it will be for two. So it's important also to have a basic knowledge of data types. And we started by talking about the string data types. Now, moving on to the numeric data types. Numeric data types are data types that have to do with numeric values. Basically, that have to do with numbers. Now, when we talk about numeric data types, we are now starting to talk about data types such as the tiny int. We know that an integer is a whole number. So the tiny int has a limit from 0 to 255. We have the small int. All of these are still integers, just that what they allow, their character limit is usually the difference. We have the integer data type that is usually called int. It allows up until at least 2 billion values, and then the big int that can go as much as over trillions. You can have quadrillions inserted using the big int. We also have the decimal data type. We have the decimal data type. The decimal data type and the numeric data type are quite similar as they allow fixed precision and scale numbers. That is, numbers that have decimal points inserted after their main values. Other data types that you find under the numeric data types include the money data type that is used for storing monetary data. That is data that contains that is formatted with currency symbols. We have floats, we have the float data type, and we have real, also similar to the float data type. So the other data types that we have include data types such as date and time. We understand date and time from our Excel, even in our Power BI, because we've had to deal with date, time, and date and time separately. So as we go on, we are going to be exploring how to create databases, how to create tables, and how to create and format databases. So far, I hope we're still together and I hope we still understand what we've been saying so far. Are we still together?
Yes, sir.
All right. Do you have any
Yes.
questions so far? Or I can proceed.
Yes, sir.
Any questions from the house so far? Or I can proceed. Okay. So I'm
No
just going to
question.
be, all right. Thank you. So I'm just going to be moving on then. Now, one of the things that is also very important for us to know in SQL as we go on is what we call constraints. You see, part of the reasons why most organizations who keep a lot of data would prefer using SQL is because of the level of security that it offers for the data that is stored within the database. And part of the ways that SQL ensures data security is through the use of constraints. Somebody raised their hands. Do you have a question?
Yes, I just wanted to request you to expound on what you meant by the level of security that SQL offers.
Oh, okay. Thank you. Now, what I mean by the level of security that SQL offers is unlike a spreadsheet that is not protected now. If a value is stored within, if you enter values within spreadsheet and it's not protected by any other external measure, anyone can go into that, anyone that has access to the um, spreadsheet can alter values within there. So what I mean by security is basically the protection of data that is stored within the database, because it cannot just be altered anyhow by anyone that does not already have knowledge of how the database came about or how the language works. So I hope you understand that now.
Yes, please. Thank you.
All right. Yeah, you're welcome. Now, moving on from there, I said part of the way that SQL ensures this level of security that I mentioned is through the use of constraints. Now, just like the word constraint, if you constrain someone or something, it means you've set a specific rule, or you've given a specific order, or you said, oh, don't go beyond this. Now, SQL constraints are used to specify rules for data in a table. Just like, let me liken this to when we learned data validation in Excel, such as that you can use data validation to set what and what not that is allowed for a particular column within your spreadsheet or within your table. Now, constraints can do quite a few things in SQL. You can use constraints to specify what can be added into a table. You can use constraints to specify what kind of action can be performed on a column within a table. And we have this as the constraint types in SQL. We have the not null constraints. Now, from the moment you set a constraint for any column, what that constraint will do is that it will set a rule for that column that cannot or must not be gone against. So take, for example, one type of constraint is the not null constraint. And what this does is that it ensures that a column cannot have a null value. So if you set a not null constraint for any column in SQL, it will mean that that column cannot contain any null values. We also have constraints such as the unique constraint that ensures that all values in a column are different, that there must be no repetition within that specific column. That's what the unique constraint does. Other types of constraints include the primary key constraint. Now, the primary key constraint is a combination of the not null and the unique constraint. Because if you declare a column as a primary key column, it means that every record within that column must be unique and it must not be empty. Just like your matric number, for a university student, they cannot call your matric number from your school and two students will stand up, because a matric number is supposed to belong to just one student. Aside the fact that the primary key is supposed to be unique, it's also not supposed to be empty. It's like writing an exam in your school and you did not write your matric number on your answer sheet. Other constraints include the foreign key. Now, the foreign key is simply a primary key in another table. That is, if you bring a primary key column from a table into another table, then over there it becomes a foreign key. And then we have the check constraint that ensures that all values within a column satisfy a specific condition. Now, I want to show us an example of what a primary key constraint looks like. And to do that, I'm just going to go to SQL Server. I hope we've been able to install SQL Server for those of us that are on the call, because we are going to have to practicalize some of the things that we learn here. So I hope we've been able to install SQL Server.
For me, I've not. I'll do it right now.
Oh, okay. All right. Please do.
Same here, not
So,
as well, but I'll do it tonight.
all right. No problem. No problem. So I'm going to go to SQL Server now. I'm going to walk us through a few things there, and I'm going to try to show us what the interface looks like, and then walk us through creating our first um, database and also tables within databases. Okay, now we've learned about databases, we've learned about SQL itself, we've learned about constraints and also data types. Now, one other major thing that we must know in SQL is that we must have the knowledge of sub-languages. Sub-languages. Now, SQL sub-languages are simply, they are the powerhouse upon which all of our queries would be. Just the same way, English language now, we have various parts of speech and figures of speech. We have the noun, we have pronouns, we have verbs, we have adverbs. Despite all of them being words, they have specific uses and they have specific functions. That's the same way SQL has major sub-languages that are essential for database management. Now, these sub-languages, they are grouped into, mainly, they are grouped into 4, because we have the DDL, that's the data definition language. We have the DML, that's the data manipulation language. We have the DQL, that's the data query language. The DQL is also called the DRL. The DQL is also called the DRL, that's data retrieval language. So I'm going to go into SQL Server now and just show us a few things from there. Now, this is the SQL Server interface. This is the SQL Server interface. This is what it looks like. When you open, let me try to open it from
I don't know if it's
connections
from
here.
my hand. Your screen is not moving. It's still showing introduction to SQL.
Oh, okay. I'm going to just stop sharing and share again. I'm going to stop sharing and share again so you can confirm together. So please let me know if you can see my screen. Please
Yes.
let me know if you can see. Okay. All right. So basically, I was about to show the. So whenever you open your SQL Server, this is what you are going to firstly encounter. This is what you are going to firstly encounter. SQL is going to ask you to connect to the server that you must have already downloaded if you watch the installation video. So I'm going to say connect. And when that connects, automatically your server will start to run live. And this will open, your Object Explorer will be opened right to the side. Now, the interface, similar to most of Microsoft's apps, has different tabs right here, and different ribbons. Now, this is your server, and your server contains access to your database, contains access to. So if you want to create a database, you are most likely going to have to open your database and don't forget, I explained earlier that a database is a collection of data. Why I said a relational database is a collection of data that is stored in one or more tables. This Microsoft SQL Server app is a relational database management system that we use to query relational databases. So I want to show us a quick picture. I want to show us a quick picture that we're going to be using now. If we want to create this database in SQL, if you want to create a database for, if you want to create a database and you want to create tables within that database manually, the first step you're going to take is when you open your SQL server, you are going to have to create a database. You can do that two ways. You can do that using two ways. Firstly, you can right click on your databases and create a new data. Click on new database. Then it will ask you to name your database. That's the database you want to create. And for this sake, I'm going to call this pet store. I'm going to call this pet store database. The DB is for database. And what you figure is that automatically it will create that database and add it to the existing databases. All of these that have this icon right next to them are databases. Now, that's way one to create a database. Way two to create a database is to create it manually by using the create DDL sublanguage. Create is one of the DDL sublanguages. And like I said before, the DDL sublanguage are the commands that we use for structuring the database, of which we have some commands underneath, such as create. You can use the create for command for creating new databases and also for creating new tables. So if you want to create a database manually using code, I'm going to click on database, open a new query. When you click on the new query, it will open SQL's query view for you and ask you to write your codes. Now, one thing I also want us to understand about SQL is that just like every language has figures of speech, has certain syntax that guides how it is supposed to be used. Don't forget that above all, SQL is a language. So that means you need to understand how to speak the language, how to use the tool to speak the language. Now, in SQL, there are certain syntax that are best practice to follow. I'm going to be sending us a best practice slide as well later during the day after our class. So we are going to, whenever you want to write code, you can just go ahead to start writing it directly. But then it's always best practice to use comments in your code. That way, if you have to share your code with somebody else, or even if you have to go through it again, it will be easy to understand every step that you are taking. Now, there are two ways to write comments in SQL. You can use the double dash to write your comments. Now, this is called the single line comment. That is, anything that you want to do must be on this same line. So I'm going to say introduction to SQL. my data click. Now, the moment you have this code written like this first line has been highlighted in green. Any portion of the code that's highlighted in green in SQL Server is a comment. Now, I said what we want to do is that we want to create a database. I'm going to add another comment and say creating my first database. Just enter to move to the next line. Now, anytime you are writing any sub-language, that is any command, it is best practice to always capitalize any command. It is best practice to always capitalize any command. Not because if you write it as a small letter, it's not going to work. Of course, it is going to work, but then it is best practice to always capitalize your. Now, I want to create a database. So I'm going to say create database, and then I'm going to name the database. I'm going to name the database. Let's call it pets underscore store. Now, whenever you're writing code and you get to the last part of the code, though not always essential, best case scenario to add this, a semicolon, because it acts as a line terminator to indicate that you've gotten to the end of your code for that block of codes. So if I run this, if I highlight this and I want to run it, it's either I come to execute or I press F5 to execute. And now SQL is going to let you know that the command has been completed, and it will also show you how long it took to run that code. Now, if you look to the side where the databases are, you will see that the pet store database is not there. I'm going to, all you have to do is to refresh. Now, this is the refresh button here. From the moment you refresh, you will see that the pet store database has now been created. The pet store database has now been created. Another DDL command that we can use for altering the structure of databases is the drop command. While we use the create to create new databases or new tables, I'm with you. I mean, as your hand is up.
Okay, please, before we go further, I just want to ask that the first one that
Yes.
you did, the first method, that pet
Yeah.
store database, and I don't really
Yes.
get it. Before we move to
Oh.
this, thank you.
Oh, okay. To the codes. All right. Thank you. I don't worry. I'm going to go over it again. I'm going to just quickly go over it again.
All right, thank you.
So take for example, yeah, I mean, if the way I created that was you right click on databases, say new database, and then you type in your database name. Let me say example now. Let the name of this database be example. I'm just going to say okay. That will create a new database quickly. If I want to
Oh,
delete this, I can just. Did you get that?
yes, yes, yes. I thought you've
All
added
right.
the database already. That's why I was confused.
Oh no 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 no.
I think.
So, oh, you're welcome. So I'm going to just right click on this database now. If I want to delete it, I can decide to rename it. I can decide to delete it. So I'm going to just delete this. Before you can delete a database, ensure you click on close existing connections. So you'll be able to delete the database. Now, if you want to, the other code under the DDL is the drop command. What the drop command does is that it, I said under the DDL, we have three main codes that we use to define the structure of a table or a database. Now, there's the create that we use to add either new databases or new tables. And then there's the drop. We use the drop database to permanently delete either a database or a table from a database. So if I want to drop this just created database, I'm going to say drop database, and I'm going to put the name of the database. So this is going to be pet store. If I close this, if I run this query and I try to execute it, SQL is running this. Let me see if it is going to give me an answer. So while that is executing, let me just quickly put a line of code. Oh, I'm actively in this pet store database. So this is another option for dropping databases. So let me just include a comment and say DDL data definition language used to define the structure. Okay. Now, aside create and drop, another DDL command. So I said we have create, we have drop, and we have alter. Alter is one of the DDL commands. We use the alter command to manipulate existing data. That is, you use it to manipulate either a column or a database. Now, let's start with how to then create tables. Let's start with how to create tables. I'm going to reference the database that we want to create a table within. We are working within the pet store database. We are working within the pet store database. So I'm going to right click the database and open a new query from there. Now, we want to create a quick table before we then create the table, the database and the table that we're going to be using for this series of learning. Now, tables in SQL are also called database objects. If you open all of these, any of these databases now, you will see that you have options such as database diagrams that allows you to do data modeling in SQL. We have tables, we have views, and a few other options. Now, if I click under this, again, this logistics database, for example, now, and I click on tables, I'm going to find that there's a table. You can see that the table is saved as DBO dot the table name. That's because tables in SQL are also called database objects. Now, how do we create a table within this pet store? There are two ways. When you create a database, you can import an already existing file, either a CSV file. Most times, it's preferable to convert your file to a CSV file before bringing it into your database. Or you can manually write the code to insert values into a created table. So as we go on during the course of this, we're going to explore firstly how to manually write code to create a table, and then how to also import already existing data into a database in SQL. Now, for this, we are going to create a table. So this is going to be, we're going to be using the create command, and we're going to say create table. This time, we are creating a table. We are creating a table. And the information that the table will contain is from here. The pet store is going to have, we're going to try to create two tables, the owner's table and then the pet's table. So this is the information that's the. Now, when you're creating a table inside of SQL, when you're creating a table inside of SQL, there are two things you must have already properly defined. Two things you must have already properly defined. Number one, the name of the table. Because when you enter create table, what has to follow is the name of the table. So for this case, the name of this table will be owners. It will be owners. You open a bracket because now you want to start to name the columns in the table and define the data types that are allowed within each column. And also, if you'd like to set constraints, you can set constraints for each of these columns. And I said earlier that constraints are simply guiding rules for what can and what cannot be done within a table in a database. So to create a table, create table, the name of the table, and then open a bracket. Now, from here, we have column names, ID, data type, integer, first name, variant, varchar, last name, the city, and the state. So I'm going to, from SQL Server, this is how you start. You start with the name of the column, the data type of the column as well is what is going to follow. The data type of the column is what is going to follow. Now, in a case where you have a column that is arranged serially, take for what do I mean by serially? A column that numbers maybe 1 followed by 2 that is increasing in order of 1, or a column that is increasing in a particular order, you can use the identity clause to say that for this column, I just want you to continue to increase it from 1. If you want it to go in a particular order, you can specify what you want the starting number to be, and then the number you should increase it by. Just like our fill function inside of Microsoft Excel. But I'm just going to leave it at identity because I want it to just increase in order of 1. As you can see in the image, that the ID column is increasing in orders of 1. 1, 2, 3, 4, 5. So quickly moving on from here, this column, the constraint that will be here is the primary key constraint. I mentioned before that the primary key constraint is a combination of the not null and the unique constraint, meaning that any column that you declare as a primary key column must not have null values and there must not be any repetition. So if you are done defining that column, you press comma and go to your next line to define the other column. So this column is first name. Now, when you are naming columns that contain 2 or more words, you cannot use a space. You have to use an underscore as a separator between both words. So the column name is first name, and the data type will be varying character. Now, if you want to set a character limit, that is maximum number of words or maximum letter of alphabets, or should I say letters that are allowed within a column that contains text, you can do that by setting a limit at the end of the data type. So if I say varchar, I open a bracket and put 30, for example. It means that no column, no row in this column is allowed to have more than 30 characters. I don't know if you understand that. Are we still together?
Yes, but please, can you take it over again?
Okay. Now, I was saying that we are moving on to the other columns. And for this, you can see that we have the first name column. Now, I was explaining that we are going to use the data type virtual. If you want to set a character limit for any column, particularly that contains text, all you have to do is open a bracket after declaring the data type and set a limit of your choice. You say, okay, don't go don't allow more than 30 characters. So take for example now, let's say a column is allowed to take only 10 characters. It means that if I want to put my full name, Favor Adelani, within that column, I won't be able to. Because while defining or creating the table, the column has been defined to take specific counts of characters. Can I hope you get that?
Yes, thank you.
Okay. Now, so I'm just going to move on quickly. After declaring this, move to the last name. So last underscore name. This would be the same as well. It will be a voucher. Now, for the city is the next. This is also going to be, and the constraint will be 30. Now, for the state, if you look at the states column, it contains just 2. And when I was defining earlier, the data types, under the string data types, I said we have char. Char is advisable to use when you have columns that don't contain a lot of characters, preferably abbreviations. So here, we can use the char data type and set our limit to 2, since we are sure that none of our values within this column exceeds a count of 2. Now, if you want to then signify that we are done creating this table, close the bracket and then add your line terminator, that is your semicolon. Now, to run this, we're going to highlight the old code and then you can press F5 or just come and click on execute. Now, SQL is going to create a table within. Can you see that the dbo.owners table has now been created? Can you see that the dbo.owners table has now been created? So this will bring me to talking about the other sublanguage. I'm still here to mention alter, but I will mention alter after I've mentioned this. We have the DML, that's the data manipulation language. Basically, you use the DML sublanguages to interact with data. So if I want to see this table that has just been created now, then I'm going to use one of the DML commands, that is the select command. Say, let me see. So I'm putting comments to this just so I'll be able to share the codes with us at the end of the class. And we'll also be able to go through it when we are creating ours to use as a guide. So that's why I'm trying to put comments so that you'll be able to use it when writing your own code. So say we use it to interact with the data. So use it to interact with the data. So if I want to view this table now, I'm going to say select. If I want to view the entire table, I'm going to say select all. And to say select all, you just say select and use the asterisk. Select and use the asterisk. And then this will take us to the other brother of the sorry about that. I'm going to select all. Now, take for example, don't forget I mentioned earlier that this thing is a language. If I want to send Isoken to the kitchen now, I'm going to say, please go to the kitchen. If he asks me, what do you want me to go and do there? I'll say, help me to take a spoon from there. Now, if he goes to the kitchen to take a spoon, I say, oh, my bad, sorry. I want you to bring the blue spoon. So the from is going to be the kitchen, and then the select is going to be what she's supposed to take. So what comes after select is usually from, and from executes first. That is okay, from so table, select this. Same way, it's going to be from a location, select this. So from is going to then be the name of the table. That from the owner's table, select everything. So this way, SQL knows where to select what from. So if I select all of this now and I execute, we are going to see all of the columns that have been created. The ID, the first name, the last name, the city, and the state. I hope we're still together. Do we have any questions?
Not for me.
All right. Now, how then do we populate after creating a table, how do we populate that table? After creating a table, how then do we populate that table? Now, let me show us what the alter command does, because the alter command is the third of the DDL commands that I mentioned earlier. Now, we use the alter command to, like I mentioned, manipulate already existing data, already existing columns. If I want to change the character limit from the first name, for example, what I'm going to use is going to be the alter command. I'll say using alter. I'm going to say using alter, and then I'm going to say alter the name of the table, owners. For this, I want to add, you can use alter to add, and you can use it to manipulate. If I want to add another column called the email column to this alter, to this table, I'm just going to say alter table, the name of the table, and then the action I want to perform. Add the name of the column, email, and the data type, virtual 50. Now, if I run this and I go back to view the owner's table, you'll find out that the email column that was not originally there has now been added using alter. If I want to drop it, the same way I added it, that's the same way it's going to go out. Just that the instruction this time will be different. So I'll copy the already existing code, and I'm going to use alter to drop the email column. The same way you can use alter to add, you can also use it to drop and go drop email. And this is going to be drop column and the name of the column. So if I run this now and I execute it, alter would have dropped that column from the table. So that's what the alter command does. That's what the alter command does. Now, in a situation where what you want to do is that we want to alter an already existing column. We're going to say alter the name of the table and say table, that's owners. And then we'll alter an existing column and say alter column, the name of the column. Let's use the last name and let's change the character limit to 50 instead of 30. If you do that, alter will help you change the character limit. Now, how to populate a table? How to populate a table? How to populate a table? To populate a table, we use the insert into command. We use the insert into command. Now, how we do that is we're going to start by saying insert into, and then the name of the table that we are inserting our values into. Now, one thing that you must note when working with SQL is, like I mentioned before, though it's not a necessity to always capitalize your commands, it does make your work a lot easier to read, and it's just best practice. Insert into, then the name of the table. So this will be owners. Then you call out the columns within that table that you have created. We are not going to call out the ID column. Reason being, we have already set the ID column to automatically fill itself per entry using identity. So we are going to start from the next column, which is the first name, the last name. From the moment you start typing, it would even already start suggesting the columns for you. I think what comes after is the city and then the state. Once you do this, you close the bracket and then you say the values that you want to add. Mind you, whatever value that you want to add must not contradict the data type you have already defined. So anywhere you have defined the data type to take integer, the only kind of data type that is allowed there is an integer. If you have set it to take a varying character, what is allowed there would be a varying character. So let me use, so to insert the values, for the first name, I'm going to use my name, Favor. That will go into the first name. After that, you're going to put a comma and then move on to the last name. I'm putting it in single quotes because the data type is a string. It's a text. If it was a number, it doesn't have to be in quotes because we are going to quickly populate our table for the course of this learning. The last name will be Adelani, and then the city would be Oyo, and then the state. If I try to add Ibadan now, for example, if I try to, if I try to add Oyo here, and I close the bracket. Now, from the moment I try to run this, it's going to return an error. Reason being, the state column has been defined to only take character limited to 2. So that means anything that I want to put in this column must not be more than 2 entries. So that's what I meant when I said that data types define the kind of data that is allowed within a column. I hope we understand that. So let me add one more to this. Let the first name be, let the last name be. These are the names that came to my head. I'm very sorry. And let the city be Enugu and the state be here. Now, there's supposed to be a comma after this to signify that there are still other values to come. The moment we highlight this and run it, two rows are going to be added to the owner's table. And if we view the owner's table now, we're going to find out that so do you get that? Can I proceed? Do you have any questions?
Yeah, so I have a question.
All right, please go on.
So does that mean the alter function is more like control Z to undo?
Well, the alter function, I wouldn't really see it as a control Z, because if you do, you still have to use the alter function to like change. But similar to that way, you can just use it to make changes, not necessarily because you've made a mistake.
Yeah. Okay.
So that's
Thank
what
you.
the alter function helps us to do. Can I proceed?
A quick question,
Yeah.
sir.
All right, Abdullah, please go on.
Yeah, I noticed that the ID column.
Yeah,
So is it start from one, started from two? I don't know.
yes. Now, the reason why the ID column started from 2 is because I already attempted an entry before that was not correct. So that's already recorded as 1. And if you look at the count from here, we already have 1 and 2. So what the identity column does is that for each attempted entry, it already starts to number. So if I made another mistake, this would have started from 3 instead. I hope you get that.
Yes, yes, yes. Thank you, sir.
Okay. All right. So having introduced us to how to create tables, the table we are going to be using for the course of our learning is what we are now going to create. So firstly, we're going to create a database. We're going to create a database, a new database, and call it the movie database. So it's going to be movie DB. And then referencing this database, we're going to open a new query. Now, what we want this database to do is to contain 4 different tables. 4 different tables. So we're going to start by saying inserting, or should I say creating the tables. So the first table we're going to create for this database is going to be a table called the directors table. It's going to be a table called the directors table. The name of the table will be directors. And then for this database, it's going to contain the first column will be the director ID. It's going to be a data type integer, and the identity is to contain we use it as our primary key. The next column will be the first name of the director. to be the first name of the director, and the data type will be varchar with a limit of 30. And then for it will be followed by the last name. Don't forget to always put a comma as you're going from table to table. And when you are naming your columns, you cannot use space. You have to use an underscore. So this will be the last name, data type varchar 30, and the constraint here will be that it must not be empty. Your last name must not be empty. Now, can you see that this constraint is appearing with a faded color? I'm going to move on to the date of birth, and the date of birth will contain the date. The data type will be date. I mentioned earlier when I was explaining the data types that we have the numeric data types, the string or text data types, and we have other data types, of which date is one of them. And then the last column here is going to be the nationality column, and this will be data type varchar. When you are done, ensure that you close your bracket, add your line terminator, and you execute this. Now from this, we are going to select. We want to view the created table. Now for the created table, to view it, we're going to use select and say select all from the name of the table, which is now directors. From the moment you start to even type the name of that table, SQL would bring out the name of the table that exists within that database. So if you decide to view it, you have all the created columns. Now, I'm also going to be, one thing that I'm going to be doing is, I'm going to be, we already have codes for this, for the values that we're going to use to populate the tables. The codes are already written out in Word format. So all we're just going to do is to copy them and to bring them in. Now, this will be for the directors. This will be for the directors. So I'm going to make this code available. Now, to insert values into the directors table, inserting values into the directors table. The first step is we're going to use the insert into command. We're going to use the insert into command, the name of the table. Don't worry, SQL is not case sensitive. So if you use even capital letter where you already use small letters before, it's still going to work. So insert into directors and then your values. So all you have to do when you want to create this table is from the values that I'm going to be uploading to the classroom, you can populate this table. So we're going to highlight this. I hope everybody got that. I hope everybody got that.
No, no, sir.
Okay. Please, if you don't get something, kindly signify.
Okay, so I don't know how these names came. How I don't know how
Oh,
they
okay.
came into it. Yeah. Like the
Okay.
names, but
So
I
I,
understand how they do putting values. It's
oh,
just the
okay.
names that I don't know.
Okay. So I said there's already a Word document that contains these values. So all I did
Yes, sir.
was to copy the values from the document, Ctrl C, and I brought them into the query by pasting.
Oh, okay, okay.
Yeah. So now, if you run this, if you highlight this up until the last value and you execute it, it's going to add 37 rows to each column. And if you go to view the directors table, can you see that? Now, for Abdullah, can you see that the director ID that we used identity for, from the first trial, the director ID goes from 1 up until the last entry. So do you understand how the identity front works now?
Yes, yes.
All right, all right. So now we are
Okay.
going to create,
So,
all right. So we're going to create other tables and populate them by bringing in their code as well. The next table we are going to create is going to be the actors table. It's going to be the actors table. So say creating the second table. Creating the second table. Put in brackets actors. Don't forget I mentioned earlier that in a table or in a database, you can have more than one table. And that's why what we are working with is a relational database management software, meaning you can have multiple tables related to one another within the same database. Now for this, we are going to start with, so if I want to create a table, can somebody tell me what are the steps I'm going to take to create this table? Can somebody tell me the steps I'm going to take to create this table?
Yeah.
Okay.
So we start with create table.
All right. Okay. So create table.
So the table
Okay.
name.
So all right. So in this case, the table name will be actors. Okay. I'm with you.
Then open brackets.
Okay. Open a bracket.
So we'll define the data types for the
Good. Thank you. So as we
types.
are as we are naming the columns, we are also defining data types. So the first column that will be in this will be the actor ID. The data type will be integer. We'll make it an identity column with the primary key, or better still, for the actor ID, let's make it an identity with the primary key inside of it. Primary key. Now, can somebody tell me the primary key here? What is it? What's the primary key that we're adding here? What do we call this primary key that we've added to this? What do we call the primary key that we've added here? If you're speaking, I'm listening. Whoever unmuted their mic, we can't hear you. If you are the one that unmuted your mic, we cannot hear you.
Sorry, I didn't get the question.
Okay, I said this primary key that was added at the back of the actor ID. What do we call it?
It's the unique identifier.
Okay, now you have said it's a unique identifier, and I agree. But then what SQL term do we call this primary key here? I'm still waiting though.
The, uh,
So we'll create this table as well. All still within this database under the tables. And you see that we will now have two tables. We now have two tables here. So if you want to populate the actors table, if you want to populate the actors table that we have just created, I'm still waiting though. I'm still waiting for anyone that wants to answer.
Is it the one we place constraint?
Yes, exactly. It's a constraint. Thank you. So we are going to insert this into the actors table. Going to insert this into the actors table. These are the values that will go into the actors table. We are going to highlight it and we are going to run it. If you execute this, 147 rows. So let's view the table. Anytime you add values, viewing the actors table, that will be the next step. Viewing the actors table, then we select. If I want to select all from the actors table, what do I do here? If I want to select all from the actors table, what do I do here?
From the table name.
Oh, okay. So I'm with you. From the table name, yes. Okay, thank you. Thank you. All right, thank you. So if you view this table now, you see that it has been populated. Are we still together? And if you take a quick glance, you would see the data that has been entered or that has been populated within that. So let's create two more tables. Let's create two more tables within this same database. Because these are the tables or this is the database we are going to be using for the course of this learning up until a significant point. So we'll create a third table and this is going to be the movies table. So we're going to call it movies. So this is going to be create table, the movies. That's the name of the table. And then we'll start to define the data type. We start with the movie ID, the data type, and then whatever constraint is going to follow. Then call out the movie name. We'll call out the movie name. The movie name is going to be voucher with a character limit of 50. The movie length, this is going to be integer. Now, from the moment where you start to see a red underline under your code, despite the fact that you are running it, you need to check through to see if you have not omitted any, because with SQL, the slightest errors, even such as omitting a comma, can lead to an error in your results. So this is going to be the movie language, voucher with a character limit of 20. This would be release date, data type date, the age certificate column, the age certificate column, which is going to be variant character 5. And then we are going to add a foreign key. Now, when I was speaking earlier, if you look at this code, the release date is showing is underlined by red. Why do you think there's an error here? I said anytime we see a red underline, it means there's an incorrect syntax somewhere. So can we look at this code and tell me why you think this is underlined in red?
There is no comma after
There is no
the.
comma after movie lang.
Thank you. Now, for the foreign key that we're about to add, basically, a foreign key is a primary key in another table. So basically, we are trying to create a relationship between two two tables. We're trying to create a relationship between two tables. Now, to do that, we are going to say this will be director ID, data type integer, and let it reference the director's table. Let it reference the director ID in the director's table. Now, what we are trying to do here is that we are trying to bring in what was a primary key from the director's table. We are trying to bring in what was the primary key from here to be a foreign key here. So why is this showing an error? Is there an incorrect syntax anywhere here? Okay, so this should close the bracket and then end it. So let's run this. If you highlight your comment as part of your code, it's still going to run because your comment is a non-executable part of your code. Okay, so this has created the movies table. And if you view the movies table, you will see the movies table. If you view the table like this, you will see that you now have all of the columns. If you refresh from here as well, and you view your tables, you see that you now have the actors table, the directors table, and the movies table. All of this, it doesn't matter when you created which, they are arranged alphabetically. Now, the next step will be to populate the movies table. To populate the movies table. Now, to populate this, there's already the code for the movies table. I'm just going to copy this and then use it in to populate the movies table. Have the values. So we're just going to highlight this as well. Let me reduce the zoom of this. 150 is just fine. So I'm going to highlight this and then run it. So this has affected 53 rows. If you want to view the updates, you can just select off from that table again, and you find out that all the values have been added. Let's add the final table. This table is going to be called the movie revenues table. So I'm going to add a comment creating the movie revenue table. That will be the fourth table. Now, for this table, we're going to start with the create table command. The name of the table will be movie revenue. And we're going to populate it with the columns that are supposed to be there. So this will be the revenue ID. It will be an integer. It will be a primary key for this. And then we're going to have the movie ID. That will be a primary key because that will be a foreign key because we already have the movie ID that is the primary key in the movies table. So this is going to, like I said, when you want to insert a foreign key, you have to reference where it is originally a primary key. So you say reference the name of the table, which is movies, and then the name of the column, which is movie ID. So if you got that, you can leave a reaction. So we'll proceed and take. Now, when I was talking about the numeric data types, I said we have decimal as a data type as well. Now, for the decimal, it allows you to set the fixed point value and the float values. That is the values before the decimal point and the number of values after the decimal point. So the first value that you enter here will be the ones before and then after the decimal points. So this is us basically setting a character limit for the before and the after. This is us setting a character limit for the before and the after. So why is it giving an error? There's no data type here. This should be integer. And then finally, we're going to add the international takings. We're going to add the international takings and also have it as a decimal. Okay, so we'll close this, end it like this, and we're going to create the table. Good. Having created this table, we'll select all from the newly created table, which is the movie revenue table. All the columns have been rightly added. Then we can populate it using the codes for the movie revenue. For the movie revenue. Don't worry, I'm going to make these codes available at the end of the class. So this is going to be the movie revenue table. I'm going to put a comment and say populating the movie revenue table. Now, from here on, I'm just going to highlight and execute, and then check the values that have been added into this table. Good. Now, if you want to check this from your actual, you can then refresh your database, and under the tables, you will have all four of your databases already rightly added where they're supposed to be. Now, I've spoken about the DDL codes. I've spoken about the DDL codes. I said we use the DDL codes. I just want to give a quick recap to define the structure of a database or of tables within a database. Talking about the DML code, I said of which we have select. Now, another sub-language that is very important after you have already created your table. When you have your database that now contains tables, one of the things that you want to do within that database will be to query it or to retrieve data from it. Because, in fact, just like the name implies, structured query language, a majority of everything that we want to do is to query. That is, get the data to answer our questions, get the data to speak to us. And that's why we communicate using SQL. So the third sub-language that I'm going to be is now the DRL or the DQL that's called data retrieval language or data query language. Now, what you do with the DRL commands is that we use them to retrieve information. So this is where select and from partner with clauses. Clauses such as where, that, okay. Now, I gave an example earlier. Let me try to use it in an SQL code. If I'm sending Miss Oke to the kitchen to get me a blue spoon, I'm going to tell her to select spoon from kitchen where color equals blue. One of the ways to simplifying understanding SQL is to firstly understand that it is a language first. If you are able to interpret it properly in English and it makes sense, just relate it to SQL syntax and it will make sense for SQL as well. Now, take for example, I'm going to go back to the directors table. I'm going to go back to the directors table. Good. Here you can see that we have the first name and the last name. I'm going to say DRL or DQL, retrieving data from a table. Now, if all I want to retrieve from this directors table is the first name and last name, all I have to do is, you see, best case practice is whenever you want to call out values from a particular table, start with from. That is from this table. So I'm going to say from directors. The moment you start with the name of the table, select will be able to auto suggest as you go on. So if what I want to see is the first name, the moment I type F, first name is already part of my suggestions. Because why? It is now already referencing a table. It's not just randomly searching anywhere. Same way I'll tell it's okay now. Okay, from the kitchen, go and pick this. So she knows she's going straight to the kitchen. That's the same way SQL knows it's going straight to the director's table to select the first name. And if I also want the last name, I'll just put a comma and then call out the last name as well. So if I say last name and I run this, if I say last name from the director's table and I run this will execute, showing just the first name and the last name. Not because the director's table does not contain more than this, but because this is what we have requested to see. SQL will not do more than you're asking it to do. And most times, preferably, if you're using a laptop that's not so powerful, don't always do select all. Don't always do select all. So I'm just going to run a few commands before we call it a night. I'm trying to be time conscious, but I know we started quite late as well. From this same directors table, if I want to see, I'll copy this code. If I want to see the first name, the last name, and the nationality, I will add nationality and then run it. If I run this, can you see that we now have the nationality added from the directors table? Now, the major powerhouse under the DRL is the where clause. We use the where clause for filtering. So let me say retrieving data using the where clause. Now, if I want to see only the directors that are Swedish, if I want to see only Swedish directors, I'm going to say select all from directors where then comes after, and I'll say where the nationality equals Swedish is declared as understring data type as the variant character. So I have to quote my condition and say, okay, where the nationality is Swedish. So if I run this now, expectedly, SQL is not meant to show me any director that is not Swedish. So if I run this, now you see that from the data, we have just one director that the nationality is Swedish. I'm going to use this on another, let me just say, Swedish directors. Let me put this as a comment so that when you're going through this later, you'll be able to understand this. So let's test it again and let's return movies with a PG age certificate. Now, from the movies table, I'm going to come back and select all from the movies table. We have age certificates and parental guidance is advised for some movies. So if you want to select those movies, we're going to start by saying select or from movies where the age certificates, that's the column that I want to filter, equals TG. So if you run this now, what you will get will be movies that are rated TG. So this is just basically to begin an introduction to SQL. Tomorrow, we are going to, I don't know if you have any questions, but I won't be doing anything new again. So do you have any questions? I don't know if you have any questions at this point. I'd like to get questions from us. If you don't have, if you don't have questions, it means you understand everything that has happened so far. Okay, Aminat, your hand is up. You can speak.
Okay, please. I just want to ask, what if
Yeah, sure.
no, you said you give us the code later on. So what
Yes.
if it's the scenario that okay, someone wanted to write codes on his own and we have large data? Isn't that we are going to be like writing for like where there's like 100 plus or 200 data like that?
Oh, okay. So basically, like I said before, when the class started, that there are two ways to populate a database with tables. You can either import an already existing spreadsheet file, that's a CSV or an XLSS file, or you can manually create it. I said what I showed us earlier is a way to manually populate a database with tables. As we go on towards the course, I'll also show us how to import an already existing um, table. So
All right,
Animat, I hope I've answered your question. Yeah.
yes, thank
All right. Thank you. So any other questions, please? This is your opportunity to ask your questions, oh, so that when we eventually get to project points, I'll be calm that you know what you're doing. Okay. All right. So in the absence of questions, I want to sincerely appreciate you guys for the consistency. There are some of you that just from this boot camp, from the activities, I know your names, I've seen your feedback, I've seen the work that you've done so far, and I'm super excited to see what you eventually do as time goes on. Thank you, Isoken, for being my spokesperson today. Thank you, Abdullah, for your active contribution. And once again, we'll be meeting tomorrow, same time, 6 to 8. A very big thank you to my colleagues for making this possible as well. Ogadi, thank you. Thank you for joining on time. New World and Isoken. And I look forward to seeing us all tomorrow, same time. The video will be uploaded on the YouTube channel for those of us that didn't join on time. And I would upload the necessary files for us to successfully complete our first trial as well. So thank you very much, guys. Enjoy the rest of your evening.
Thank you.
Thank you.
Thank you. Thank you.
Thank you so much,
Thank you.
Staff
Thank
for
you.
your
Thank
for
you.
everything. Have a good day.
Yes, sir.